Hello students, welcome you all in the first lecture of the transformer, working principle and E.M.F equation. So we all know that transformer is a static device which transfers electrical energy from one circuit to another without a change in frequency. When transformer raises the voltage, that is, if output voltage is greater than input voltage, then it is called step up transformer. And if it lowers the voltage, that is, output voltage is less than input voltage, then it is called step down transformer. So, first is working principle of the transformer. So we all know that working principle of the transformer is mutual induction, according to which changing current in one coil induces an E.M.F in the other. So an elementary transformer consists a magnetic core that is made up of laminations to reduce the eddy current losses. So these dark lines, blue lines, are showing laminated sheets. So like this, we always use laminated core, right? And it also consists two windings placed on it. One is called primary winding and another is called, this is secondary winding, right? This is primary winding having n number of turns. And this is secondary winding having n2 number of turns, suppose. Now when we apply single phase supply V1 voltage, input voltage, then a current, input current, starts to flow through the primary winding, that is I1. So when this single phase supply V1 voltage is applied across the primary winding, then input current I1 will start to flow, and this alternating current will flow through this winding and will create a magnetic flux. This is also alternating. So when this current will flow through the primary winding, alternating flux will link to this primary winding, to this core, and as well as to this secondary winding. So due to mutual induction, due to self-induction, an E.M.F, E1 will be induced in the primary winding, and due to mutual induction, E2 will be induced here in this secondary winding, right? And if we connect a load across the secondary, then due to this E2 E.M.F in the secondary, a I2 current will flow through this load, and V2 voltage appears across the load. So this was about working principle of the transformer. Now EMF equation. So the flux produced by I1 current is alternating, that is linked to core as well as to the both windings. So this is the one cycle of the EMF equation. This is total time period T, and this will be T by 2, and this will be T by 4. And we know that frequency is reciprocal of time period, so it will be 1 by 4f. And this is maximum value of the flux. Here also. So this flux increases from its zero value to its maximum value in T by 4 time, right? So we can write rate of change of flux is equal to d phi by dt. And this will be equal to phi m divided by 1 by 4f. So we can write this phi m into 4f or 4f phi, right? And this is the average rate of change of flux, and this will be equal to average EMF induced per turn of the coil. Per turn of coil. Since flux varies sinusoidally, so EMF induced will be also sinusoidal, and form factor of the sinusoidal is 1.11. So we can say RMS value of EMF induced per turn will be equal to for RMS value, we will multiply the form factor to this EMF equation. So this will be equal to 4.44 F by M. And this is the EMF equation for one turn only. And if there are n number of turns, if there are n number of turns in primary and n2 number of turns in secondary, so total EMF in primary winding will be equal to 4.44 F5M into N bar. Similarly, EMF in secondary winding will be 4.44 F5M into N2, right? EMF induced in secondary will be equal to 4.44 F5M into N2, right? So, suppose this is the first equation and this is second equation, right? So, these are equations of EMF induced in primary winding of the transformer and secondary winding of the transformer. So in this lecture, we discussed basic working principle of the transformer and EMF equation of the transformer. This is reference from which I have taken the content. Thank you.